Now let's see this example. Let f of x equal to mod x minus 1 plus mod x plus 1. Discuss the continuity and differentiability of the function. That is what is given. So this is the part of the solution. So first of all, whenever such functions are given, you can see that the functions are of form mod x, okay, it is a combination of two functions. One is mod x minus 1 and the other is mod x plus 1. So if you try to look at the graph for mod x minus 1, you will see that it is going to look something like this. At a point 1, it is going to have something like this, okay, which means at a point 1 there is a corner point for this. Now if you look at this one, mod x plus 1, then at a point minus 1, it is going to have, when x equal to minus 1, it is going to have a corner point. Therefore it is clear that if you have to check whether it is differentiable or not, you have to find out the left derivative and the right derivative at these points minus 1 and 1. Got it? Then only you can go ahead with that. So that is why I am trying to find out how the function is behaving to the left of minus 1, to the right of minus 1, to the left of 1 and to the right of 1, right? So let's see what their values are. Now f of x to the left of minus 1, what happens to this? Now to the left of minus 1 means you can assume that this number is less than minus 1. You can say the number is minus 1.5. Now if you take the value minus 1.5 and you substitute here, it is going to be minus 1.5 minus 1, which means minus 2.5, which means the total number is negative. Since the total number is going to be negative, in order to convert into positive, if you remove this mod, then you have to multiply with minus 1. That is why I am multiplying with minus 1. Got it? And now if you substitute again minus 1.5 here, again this number is also going to be negative. In order to make it positive, you are supposed to multiply this with minus 1. Now you are multiplying with minus 1. So minus 1 here and minus 1 here. Got it? And what about between minus 1 and 1? You can take any example. Let's say you are taking 0. Now if you take 0 here, it is going to be a negative number. Therefore multiply with minus 1. And if you take 0, it is going to be a positive number. So leave it as it is. Got it? And then to the greater than 1, to the right of 1, let's say you are taking a number 2. If you take a number 2, it is going to be positive, it is going to be positive, so leave them as it is. So this is how the function is behaving. Well, I mean, when I join these two functions, they are behaving this way. Now if you simplify them, you are going to get this minus x, which means minus 2x, right? And plus 1 minus 1, they are going to get cancelled away. And what about here? Minus x plus x, they are going to cancel away, and 2, 1 and 1, which means 2. And what about this? 2x. Got it? So I got minus 2x, 2 and 2x for this. So which means if you try to draw it in a graph, you are going to see something like this. From minus 1 to 1, the value of it is going to be 2. Right? So which means you are going to see the graph something like this. And less than minus 1, it is going to be minus 2x. And greater than 1, it is going to be 2x. So again, if you see this, the corner points are here only, right? So whenever you have any such corner points, right, or these are also called as kind of vertices, right, edges. So now whenever you have the sharp edges or the corner points, there is a chance that the function may not be differentiable at that point. See, one thing is definitely it is continuous. You can see that there are no gaps or there are no jumps. Therefore, it is definitely continuous, but it is not. It may not be differentiable. We have to check it, right? So, what are the various methods we can check it? Is one simple method is, since we know that it is clear, right? From here it is continuous. Or if you want to check whether it is continuous or not, you can check it. So, how to find out whether it is continuous or not? You go to this point minus 1. Find out the left limit. So, what is the left limit? To a point just to the left of it. Now what about this? It is going to be minus 2x, isn't it? See, I am talking about this value, this function, this entire function at a point to the left of minus 1. Now it happens to be minus 2x, right? Now what is minus 2x value at x equal to minus 1? It is going to be 2, right? Or if you want to find it, you can find it this way. I am talking about left hand limit at x equal to minus 1, right, which is nothing but limit x tends to minus 1 minus f of x. This is what I want to find out, right? So which is nothing but minus 2x. In minus 2x, if you substitute minus 1, it is going to be plus 2. So this value is going to be plus 2. And what about its value at minus 1? It is going to be 2 only. Now what about the value to the right of minus 1, sorry, to the right of minus 1 is again plus 2. Therefore its left hand limit is equal to the value at that point is equal to right hand limit. So we can say that it is continuous at minus 1. Similarly, you can do the same thing at plus 1. Now how to do it? Find out the right side limit, right hand limit, and at the point what the value is, and then in the left hand limit, right? Now if you try to find out the right hand limit, you are supposed to use this function y. At a point to the right of 1, the function is 2x. Now in the 2x, if you substitute x equal to 1, you are going to get 2. And now at x equal to 1, the value is 2. And also to the left of it, the value is 2. Therefore left hand limit equal right hand limit, it is continuous, right? And the value at that point. Therefore it is continuous at minus 1 and 1. And anyway at all the other points, you can clearly see that it is continuous. So what can we say? The function is continuous at all the points. Now only thing we should check is whether it is differentiable or not. So how to find out differentiability is, since it is already known that it is continuous and there are only 2 points where it might fail, we can check the differentiability only at these 2 points. That's it. Okay. Now that too we can use f dash method. Now I want to find out f dash of x, and I want to find out the left limit for minus 1, which means f dash of minus 1 minus, this is what I want to find out. I want to find out left limit at minus 1, which means f dash of minus 1 minus, right? Now if I am talking about a point which is to the left of minus 1, then this is what I am looking at. Now find out its derivative. We are going to get minus 2, isn't it? That's it, minus 2. So what does it mean? The left hand limit at x equal to minus 1, the left limit, or sorry, the left derivative. I am talking about left derivative, okay? The left derivative at x equal to minus 1 is minus 2, right? Similarly, find out the right derivative. So what is right derivative? F dash of minus 1 plus. This is what you have to find out. Now when I say minus 1 plus, I am talking about a point to the right of minus 1, which means I am talking about this one, correct? Which is clearly 2. Now if I try to differentiate it, it is nothing but d by dx, right? So this is going to be 0. Now what do you understand? The left limit, sorry, the left derivative is minus 2 and the right derivative is 0. Therefore at minus 1 it is not, differentiable or derivable. So clearly it is true. Why? Because it is the corner point, right? So therefore we can say that it is not derivable at that point. Now what about 1? So in order to check for 1, you can find out. 1 is left derivative at x equal to 1, which is nothing but f dash of 1 minus. If I find out f dash of 1 minus, right, which means I am talking about a point to the left of 1. So to the left of 1, the point is this, the function is this. Find out the derivative. So d by dx of 2. Since it is a constant, I am going to get 0. Therefore left derivative at x equal to 1 is 0. Now what about right derivative? So for that you have to find out f dash of 1 plus. So what is it? So it is find out the function to the right of 1. So which means to the right of 1 is this one. You find out the differentiation of this, which is 2 into d by dx of x, which is nothing but 2. Got it? So therefore we got 2 here and we got 0 here. So we can say that the left derivative is not equal to right derivative, and so the function is not derivable at this point 1. So what can we say? The function is not derivable at these 2 points, and other than this all the points there are no, everything is smooth, so it must be definitely derivable at all the other points, right? The function is continuous at all the points and the function is derivable at all the points except 1 and minus 1. So that is what they asked. Discuss the continuity and derivability of the function. Got it? So it is not derivable at this point and at this point, and it is continuous throughout the range. Got it? Okay. So one more point is, whenever you have a function like mod x minus a, definitely this function will have a corner edge or that sharp edge at x equal to a. Therefore at this point it will not be derivable. You can remember that. Okay. So which means if we have mod x plus a, then at x equal to minus a, it is not going to be differentiable or derivable because it is going to have a sharp edge. Right. So how to find out is, whenever you have mod, let's say ax plus b, now where is it not derivable is, you have to equate this entire thing to 0, which means you can say ax plus b equal to 0 and you find out that value, which is nothing but minus b by a. So at this point generally it will not be differentiable or derivable. If you have any doubt, you can just check at that point, right? Which means you can do this method and you can check it. Got it? So the points you need to check are this, whenever for this one a, for this one minus a, and for this one minus b by a. These are the points at which you have to check whether it is differentiable or not. Okay, fine.